Multi-step equations. As you might imagine, since we've had a video on one-step equations and two-step equations, multi-step equations is everything else. It takes more than two steps. So don't panic. You already have the tools you need to do these. These could get very, very complicated, but I'm just going to keep these like they are on IXL. So we'll do a few easy ones, we'll do a couple of harder ones, but they should all look like ones you're going to see on IXL.com. Once again, if you're watching this and not part of the Martha O'Brien Adult Ed program, you may not be using IXL.com. So that's why I'm using these specific examples, though. All right, so here we have 3, and it's being multiplied times these things in parentheses. So this means 3 times x plus 2. So it means 3 times this whole thing, not 3x plus 2, but 3 times this whole critter right here equals 21. And there are 2 ways to do this, and again, I typically don't like to give choices. I like to say, this is the way you do these, and then as you discover other approaches, it's all the same math, maybe just doing things in a little bit different order. But depending on what you come across, you might want to have some options here to be a little bit flexible. First way we're going to look at this is the way they explain the problem should you miss one on IXL. So if you miss this on IXL, the explanation would work like this. It's going to say that we have 3 being multiplied times something. Now, the something is a lot of stuff going on in parentheses, but it does not change the fact that this is 3 times something equals 21. And in order to deal with that, one thing we can do is say, well, if I've got something times 3 equals 21, if I divide both sides by 3, then I'm just left with this part right here on this side and 21 divided by 3 on the bottom. So basically, anytime you're multiplying on the top and bottom of a fraction, which is how we write our division problems, we can cancel the things that match. And over here, 21 divided by 3, of course, is just 7. So what's going to be left on this side? X plus 2. Now, the only thing we have left is to get rid of the 2. And we do that by subtracting. Since it's being added to x, we are going to subtract 2 to leave us with x. And I moved that over just a little bit, moved it up to give me just a little more room. X plus 2 and then minus 2, well, once again, these are going away. X equals 5. And of course, let's plug this 5 back into our original equation for x. So if x is 5, 5 plus 2 is 7 times 3 does equal 21. Now, if you were paying attention, and I certainly hope you were, I'm not making these videos for my health, you know. You notice that I said these were multi-step equations that were more than 2 steps. That was actually only 2 steps. They do get a little bit more complex as you go along in the exercise. But there's another way to do this, and sometimes this way might be more helpful to you, just depending on what's going on in the equation. So this second way, and again, we're not doing any different math, we're just doing this in a slightly different order. What I want to do is I'm going to bust open these parentheses. Bust open parentheses, as you might imagine, is not actually a math technical term, but I like it. And the way we're going to do that is to recognize that this is an example of the distributive property. I can take 3 and multiply it times everything that is being added or subtracted in parentheses. So in this case, 3 times x, I'm going to draw these little, you don't have to draw these arrows, but just kind of making it clear that I'm going to multiply 3 times everything that's in here. So 3 times x, we don't know what x is yet, so we're just going to call that 3x. And then the 2 is positive, the 3 is positive, and 3 times 2 is 6. Alrighty. Now, we work this like, it looks like this would be a 2-step equation at this point. I'll subtract 6 from both sides. That gets us 15 on this side. This goes away, gets us 3x. The second step, divide both sides by 3. And you find out x equals 5. I'm not going to check it, because we've already checked it. We already knew what the answer was. Okay, this one is also not exactly a multi-step problem. It's only 2 steps. You don't have to sort out how many steps it's going to take you before you even solve one of these problems. The idea is that as you get a little more advanced, it takes more and more steps to solve the problem. And this is a tool you're definitely going to want in your toolbox, and that is this idea that when you have a fraction like this, even if there's something complicated going on the top, t minus 3, you can still multiply this whole thing by 4, and let's do that. So there's t minus 3 on the top, and I can multiply that by 4, of course, on both sides, or your seesaw gets unbalanced and your friend goes flying off. Okay, now, why did I do this? Because we've divided by 4, we've multiplied by 4, so those cancel out, and we see that t minus 3 equals 8, and then obviously we can just add 3 to both sides. And I happened to see a problem that had the letter t as the variable, and I apologize because my t's and my pluses look alike. But this is t minus 3 equals 8. We added 3 to both sides, so we get just plain old t on one side, and 8 plus 3 is 11 on the other. If we plug that 11 back into the original equation, 11 minus 3 is 8. 8 divided by 4 does equal 2. So from here on out, as these get more and more complex, I don't want to say difficult, because really once you understand how to do this, it's just a matter of doing the same sorts of things over and over again. But here we definitely have a multi-step equation. So again, we want to think about sort of our reverse PEMDAS. We want to deal with the adding and subtracting first. This isn't connected to a variable. It's not inside parentheses. I could bust out the parentheses first, but I think the easiest thing would be, let's just subtract 4 from both sides and just make it a little neater here. Alrighty. So this goes away, and I still have this whole thing here. And 13 minus 4 is 9 in many countries. So now you get your choice. I'm going to do this like they do it on the IXL exercise. We also did these by simply multiplying 3 times everything in the parentheses with the distributive property. But I'm going to go ahead and divide both sides by 3. And those cancel. We'll get an x minus 2 equals 3. And we add 2 to both sides. Hang on, let me try to make this a little smaller to give me some room. There we are. We're just going to add 2 to both sides. X equals 5. And again, now if you were actually taking the high set, you'd have multiple choice answers. You don't even need to do this algebra necessarily. You could simply plug in each answer choice in for x and see which one works. So why am I teaching you how to do this? Well, first of all, you should know how to do this. Second of all, if you're going to college after you pass your high set, this is the very basic algebra that you will need to know to do college algebra. And third, they have ways of asking you questions where you can't just plug in the answers. Sometimes they might ask, in which order would you do the steps to solve this equation? So you're gonna have to know how to do these. All right. So 5 minus 2 is 3. 3 times 3 is 9. And 9 plus 4 is 13. Our answer is correct. So at this point, I'm kind of working through some of the IXL exercises and looking for types of problems that present interesting little twists or challenges we haven't really covered yet. Here's one we haven't talked about. There's a y on the bottom here, so negative 12 is being divided by y. And so what we need to do is get y sitting there by itself on one side. That's always the goal, but we don't want it on the bottom of a fraction. We need it up top. So here's the way you deal with this. Let me rewrite this. So I've got a little more room after that. And we're also throwing some negative numbers in here. Try not to stress out about negatives. You will have your calculator to help you with the negative numbers, but your life sure will be easier if you're pretty good at it in your head as well. All right, what I'm going to do, anytime there's something on the bottom of a fraction and you need it to move up top, what I can do is I can multiply both sides by y. Now, why am I doing this? Why? Haha, get it? Why? All right, I've been doing too many of these, getting a little punchy, but here we go. Because I can cancel on this side, and now on this side, on the right, I have a negative 4y, which is what we're used to. So negative 12 on this side, negative 4y on this side, and this is now, that is an ugly y, my friends. This is now what you're used to. It's just a one-step equation at this point. So all I need to do is divide both sides by negative 4 because that's what's now being multiplied times y. All right, and then negative 12 divided by negative 4 is positive 3. And over here, our negative 4's cancel out. Y equals 3. As always, we want to double check by replacing the y with 3 up here in our original equation. And negative 12 divided by 3 is in fact negative 4. As you get good at this sort of thing, you'll actually realize that what we've done is we've just swapped these two. But that would be just me giving you a technique without any explanation whatsoever. It'll be hard to remember. So for now, just do it the way we did. The y is on the bottom here, so let's multiply by a y on the top so that we can cancel them out, and then we'll have a nice term over here that just has a negative 4y, nothing on the bottom of the fraction at all. Here's another one that's a little tricky, not because it's any different as far as the number of steps. It looks kind of the same as ones we've done. It's because of this 0. So watch what happens here. Let me rewrite this real quick. X plus 10, that whole thing is being divided by negative 4. I'll leave a little bit of space. All right, how do we solve this? Well, I want to get this 4 off the bottom, this negative 4, so I'm just going to multiply this times negative 4 on both sides. The negative 4's here will cancel. But you know what? Anything times 0 is simply 0. That is not going to change anything about what we do. Just, it might look a little weird, so I thought I would do one with a 0. Now we just go about our business the way we're used to. Subtract 10 from both sides. We get an x over here, and a negative 0 minus 10 is simply negative 10. And if we go and plug that back up in the original equation, negative 10 plus 10, those are actually by definition equal to 0. They're additive inverse. When you have a number and the negative version of that number, when you add them up, you get 0. Negative 10 plus 10 is 0, and 0 divided by anything, in this case negative 4, is equal to 0. So we're done. And at this point, you've seen most of the problems on IXL that you will do in this particular section, most kinds of problems. There might be one or two that look a little different and are confusing. Don't be afraid to miss one on IXL. There'll be explanations there that hopefully you can follow. And good luck.